Dear students, welcome to today's online session. This is the last class in Unit 1. The Unit 1 last topic is performance, security, and energy efficiency in cloud computing. Performance, security, and energy efficiency in cloud computing. So these topics we'll discuss in today's class. So let us share my PPT screen. The title of this today's topic is performance, security, and energy efficiency in cloud and distributed data computing. Let us move to the topics which are covered under this. Here, focus on three factors. The first one is performance. How to improve the performance of a cloud computing. And the second one is security, providing security for a product, cloud-based product or cloud-based application. And energy efficiency, how to provide or how to minimize the energy efficiency in the distributed and cloud computing. Let us see in this today's class. Here the performance will mainly depends on the metrics and scalable analysis, and the performance depends on the fault tolerance and system availability. Whereas security concern will focus on network threats and data integrity in cloud computing. And finally, energy efficiency, how it is impact on distributed computing systems. So we will discuss these four topics in today's class. Now move to the topic performance, security, and energy efficiency. Let us discuss about what is performance. Performance metrics and scalability analysis of cloud-based software services are necessary for future optimizations and the growth of cloud computing. It means that performance is always depends on three factors, namely scalability, elasticity, and finally efficiency. And finally, efficiency. Using the term performance metrics, the cloud computing growth can be optimized. The growth of the cloud computing can be optimized with the help of the performance factor. So, how we can measure the performance of an application, or how we can measure the performance of a product, that always depends on three factors, namely scalability, elasticity, and efficiency. Let us discuss these three clearly in next topic. What is scalability? Where we are using scalability? Scalability is nothing but it is having the structure of increasing, that is called upgrading the scale, somewhat decreasing, that means that decreasing the scale or downscale, upgrade scale or downgrade scale. When we really impact this type of scalability is, let us consider a simple example. If your server is running with a huge traffic, whenever a server is running with huge traffic, when the load on server runs beyond the capacity of the server, at the time, sometimes the server may down, sometimes the server may crash due to heavy traffic imposed on that. So to overcome the problem, we need to automate that by adding new servers to the existing server based on the demand and service. So this means that whenever a huge traffic imposed on a particular server, the server running with huge traffic in any situation or scenario, we need to upgrade the capacity of the server by adding new servers to the existing server. That can be considered as a upgrading the server, that is called as a scalability, upgrading the scalability. So based on our requirements, automatically the servers will be upgrade or the servers will be downgrade automatically. That is considered as a scalability. So in technically we can consider scalability means nothing but scalability is the ability of the cloud layer to increase. Here what we are increasing, the capacity of the software services delivered by expanding the quantity of the software services that is provided. Here focus on two terms. One is capacity of the software and quantity of the software. Capacity of the software is nothing but the the maximum workload a software can bear. Whereas quantity is nothing but how many quantities or how many number of services are really required to run the capacity or to build the capacity, existing capacity, that is called as a scalability. Here there are two factors, namely auto scaling and load balancing. Very important terms, these two consider are futures. These features provide the support for cloud-based applications for providing more scalable. Auto scaling is nothing but based on the traffic imposed on the cloud will automatically perform the task as upgrading or downgrading automatically. That is called auto scaling. And load balancing is nothing but whenever huge traffic imposed on a particular server, the server will divert the traffic among the networked remaining servers. Here all the servers will running with equal amount of traffic. None of the server in that network or sit idle, through which all the all the servers available in a particular network are running with same capacity of workload, due to which we can avoid the security features or we can avoid the processing. So that is called as a load balancing technique. And next one is if elasticity. Elasticity is also one of the another factor. Here we can consider that elasticity is nothing but actual amount of time or actual amount of resources are really required for performing any point of view based on our requirement. That is called as a elasticity. So another one is efficiency. Efficiency here focus on two terms. The first one is quality of the software and the another one is quantity of the demand. That means that efficiency is the measure of matching the quantity of the software services available for delivery with the quantity of demand for the software service. That means that so the efficiency of any application or the efficiency of any software products will be mainly depends on two factors or two concepts. The first one is quality and the second one is quantity. Here the quality and quantity are which are interrelated together. If we can balance these two, we can automatically we will maintain the efficiency. We can say the server or the cloud is running with very efficient manner. So my dear students, here we should remember this true very well for maintaining the scalability or maintaining the elasticity or maintaining the efficiency. These factors well advanced in for any organization. We can consider that all the products are developed or running in that organization are successful in the market. We will give assurance for that. Now we will discuss about elasticity. As we discussed about elasticity in last slide. So pictorial graph, how this elasticity will work, we will consider here. Let us consider the graph. Here, the graph can have four different measurements. Here, the first one is which here which curve here actually demand is red color and the capacity measured in blue, and over provision is another one, and under provision is another one. That means that elasticity is nothing but actual demand. What is the present demand in the market? Suppose present demand in the market is nothing but at a time only 1 lakh members are accessing a particular website. That is considered as a actual demand. Capacity. The maximum capacity for hosting the website is 1 lakh only. So if the actual demand and the capacity are equal, then no need to improve the elasticity, no need to scale up and no need to scale down. Suppose if the capacity of the server is less than the actual demand, at the time we need to improve our capacity by adding some services over here, because for maintaining the stability, to overcome the problem, we use the term as elasticity. If we consider elasticity, sometimes over provision, sometimes under provision. Over provision is nothing but when we consider over provision is when the actual demand is very low based on the capacity, that is over provision. When the capacity is more than the actual demand, that is considered as a under provision. And next we will move to another one is scalability. Here scalability is also another factor. Here scalability, as we discussed here, we sometimes based on the demand we need to upgrade, we need to downgrade automatically by using auto scaling. Here suppose for example many users trying to access the servers. Here there are 1, 2, 3, 4, 4 users are trying to access the server. If the capacity of the server is not sufficient, then only we need to add more servers to balancing the traffic over the cloud. To overcome the problem, we use one technique that is called as a load balancing cloud. Load balancing is nothing but the traffic which is incurred on the cloud that can be shared among two different uh, available servers here. So here these two servers will share the information and load, and they can running with equal workload. So finally, due to which we can successfully run our application without any problem. That is considered as a scalability. And here let us consider another example, how to achieve the efficient and scalability performance over a period of time. With an example we will discuss here. Let us consider a typical experimental example here. Here if you consider the graph A, here the graph A we are tested with one server EC2, Amazon EC2. EC2 stands for Elastic Cloud 2. This is one of the services provided by Amazon Web Services. Amazon Web Services is providing one cloud services that is called Amazon EC2, Elastic Cloud 2. So here, study rise and fall of demand. That means that here the x-axis we can measure the time and the y-axis we can measure as a demand. So here the initially we can start the demand is very less and the demand is rise steadily. The demand is rise steadily over a period of time. It will reach the peak point and it is gradually falling the demand for meanwhile or for a particular duration of time. That means that here suddenly or stepwise not occurring. So the rising and fall down of the demand and supply is steadily growing or steadily falling for a couple of days. So if you consider the second diagram here, the Microsoft Azure, consider an example, in that Microsoft Azure cloud, the demand and time will consider depends on two things. The first one is whenever the demand, the series of stepwise increase and decrease of demand. Here there is no study here. The demand and time is not stable. Sometimes the demand is high, sometimes the time is very less, due to which we cannot estimate that whenever demand is there and whenever the demand is not there. So this type to predict this type of graphs is very difficult because when we cannot say when the demand will rise and we cannot say when the demand will goes down. So if this scenario will occur, we cannot scale down automatically or we cannot scale up automatically. To overcome the problem, the best solution is improve the scalability or improve the performance for a particular cloud over a period of time. If you consider these two demand scenarios as shown in these figures, the first scenario follows a steady rise and fall of demand pattern, whereas the second scenario consists of a series of steps, increases and falls in demand. Here, the cloud resources must be adequately configured to measure up the workload in order to achieve efficient performance and scalability. So finally, we can conclude that the efficiency and performance of a particular organization will mainly depends on the experiment results based on the demand and supply. Next, the performance metrics are why we need performance metrics. Performance metrics are needed to measure various distributed systems. The various distributed system measurement in terms of size, in terms of scalability, in terms of application or technology. So these dimensions we can measure based on the performance metrics only. Suppose, for example, how we can measure the CPU speed. To measure the CPU speed, we measure in terms of MIPS, whereas the bandwidth or the internet speed over the particular network will be measured with the help of Mbps, 100 Mbps, 10 Mbps, like that only. So these are well-defined metrics for performing or measuring the performance over a period of time in the scalability analysis. And this is also another performance of the system. Performance system will depends on the main concept is fault tolerance. What is mean by fault tolerance? Very important one. This one, fault tolerance refers to the ability of a computer or a network or a cluster or a cloud, anyone, the ability of any system to continue operating without interruption when one or more of its components fail. That means that whenever we are working in a network or distributed operating system network, In that network, many computers or many servers are interconnected to one each other. In this scenario, a well-defined communication among client machines and server machines is established through a well-defined network. In this scenario, if any server machine fails, the entire process system not fails. Why? Because if one server fails, the traffic will divert to another server machine. The traffic will divert to another server machine with the help of load balancing. So due to which we can reduce the failure of the system. So to overcome the problem, we use one of the new technology that is called as a fault tolerance. If we applied fault tolerance for a particular computer or a network or a cluster, means group of servers or a cloud, we can say that there is no failure in that component. So that's why fault tolerance is one of the very important measurements for performing the task in any operating system. The main objective of creating a fault tolerant system is to prevent what we are preventing, disruptions arise disruptions arising from a single point of failure. Anywhere we can fail, the data may be failure at any point of view. Ensuring the high availability and business continue of mission critical applications or systems. So that means that suppose for example, if we are planning to book an IRCTC, book a ticket, train ticket through IRCTC website. So the IRCTC is well connected with many servers. If whenever the person send one request to the server for booking the ticket, the server fails due to some problem, the ticket may not be generated. Generally, that that can be happen when if our server is communicated with the server, if our client machine is communicating with the server machine. When the client machine and server machine is well connected to the network, like a distributed network or parallel network. In this scenario, if one server fails, the server will divert the traffic into the another server. Automatically, the another server will take the request, the ticket booking request, and it can process the data. Finally, the processing it. Finally, the ticket will be generated, and the response will communicated to the client automatically. This type of facility will be there. So if we apply fault tolerance for any applications, there is no failure at all. And fault tolerance will mainly depends on the system availability. That means that if we apply fault tolerance for any application, always the system will be available in working mode. The system availability will be considered based on the formula. The system availability is to be calculated. System availability equal to MTTF by MTTF plus MTTR. Here, MTTF stands for mean time to failure. Mean time to failure is a basic measure of reliability for non-repairable systems. It is the mean time expected until the first failure of a piece of equipment. That means that mean time to failure is nothing but consider 1 hour time. During 1 hour time, how many IRCTC transactions are failed? And we can separate the failure IRCTC transactions in a particular database. So we can consider that the mean time to failure for failure transactions is equal to some number. So that is nothing but MTTF is nothing but you can consider a time period. Over the period of time, how many transactions are really failed? That is considered as a mean time to failure. And Mean time to repair. Mean time to repair is nothing but the time needed to repair or to success a failed hardware module or software module is considered as a mean time to repair. So finally, the system availability is considered as mean time to failure divided by mean time to failure plus mean time to repair. That is considered as the system availability. Here, let us consider three scenarios. If we apply the fault tolerance for three scenarios, the first one is hardware system. If we apply, that means that sometimes the hardware systems or the hardware components in a particular system will fail you. When the hardware component or hardware system failure over the network, which are interconnected to the internet, in this scenario, the traffic over the hardware system will divert to the identical or equivalent system automatically. For example, here a server can make fault tolerance by using an identical server running in parallel with all operations mirrored to the backup server. Suppose let us consider there are 10 servers which are interconnected together. If one server is failure, when the traffic on the particular server will divert to another availability server without any disturbance. That is called as a hardware system. Fault tolerance. When we apply fault tolerance to the software server systems, the software systems may not be disturbed. How it is, we will discuss here. For example, take a database. In the database, the customer information is continually stored. Whenever we require, we can retrieve the data from the database. Suddenly, if the database server failure due to some reasons or the database server goes down due to some reasons, the operations that is nothing but insert, delete, update, these operations can be automatically redirected to the second database that is considered as a backup database, due to which the transactions may not be failure. And third one is power sources. Power sources is also, if we apply fault tolerance to a power source factor, that means that, for example, many organizations or IT companies have or they are maintaining very powerful generators that can take over in the main line electric failures. So due to power failures also, we can protect our system when we apply fault tolerance for this scenario also. Now we will consider here, we will compare the difference, two difference over fault tolerance and high availability. As we said that fault tolerance, if we apply for any application, it can provide the assurance for 99.999 percentage. That means that the success rate or the accuracy of a particular product is success of the particular product is 99.999. So that means that the product is almost almost very secure. The product is running with very secure manner. There is no failure at all. So the failure is very low, very, very low. So that's why fault tolerance is one of the technique that can be applied for various applications or systems to avoid the failure or to minimize the downtime, and the accuracy of fault tolerance is 99.999 percentage. And what is high availability? High availability is depends on two things. The first one is the ability of the system to avoid loss of service by minimizing the downtime, and it's expressed in terms of system uptime as percentage of total running time. So that means that high availability refers to avoid the loss of service by minimizing downtime. So the system failures will be minimized based on the high availability of the system. So that's why fault tolerance will automatically boost the capacity of high availability. So friends, students, as of now we discussed we focus on only one thing, that is called as a performance. How to improve the performance of a system in cloud computing as well as distributed computing. That can be done by using fault tolerance technique. That can be done by using a high availability technique. Let us move to another one, load balancing. So if you consider the graph here, how load balancing, how the traffic for a particular server will be shared among other servers, we will discuss here. Consider a system, a web application that can want to communicate with the server. Here there are huge traffic. The traffic will be diverted to the over many data centers. Here, what are the traffic coming or goes from the client machine, and the traffic will be diverted, and the traffic will be shared equally among three data centers which are available here: data center A, data center B, and data center 3. The traffic will be splitted equally and shared to these three data centers equally, and here, due to which the performance of the system is very high, and there is no failure of the data. Why? Because if one data center failure will occur, the traffic over a particular data center A, that can be diverted into the data center B. When the data center B is also failure occurs, when the data center is already failure, and the total burden or the total traffic will be diverted into another data center C. If the data center C also failure, that means that when these three servers will also failure, and the load balancing technique will move or divert the traffic to X traffic by, to another data centers with the help of scalability. That means that scaling up the capacity of the server automatically by including or by adding new servers over a period of time on a network, that is called as a load balancing. Load balancing is nothing but the load balancer will distribute or share the traffic among equally for all these three data centers. Balancing the load among these three data centers, that is considered as a load balancing. If the traffic will divert to a single standby server, when there is a failure of a standby server, what will happen? The entire process will be stopped in middle. So there is a scenario of failure will occur in this scenario. Why? Because there is no diversion, there is no availability of extra server for diverting the traffic over a period of time. To overcome the problem, instead of maintaining a single server, if we applied load balancing with the different servers, we will be in the safe mode. So, friends, we discussed performance factor. Now we move to the second one is security. Before talking about security, the key success factor for any product or any application in the market will be mainly depends on the security. If you purchase, if you purchase a smartphone, the success of the smartphone depends on security factors maintained by the product. If the security of a smartphone is not well maintained, the product is no longer stand by very good in the very good features in the market. That's why more importance on security. Here, Security will depends on two factors. First one is data security, data integrity. Both are interlinked together. What is data security? Providing security to the data over a period of time from getting losing the data or destroy the data or getting access in an unauthorized manner. If you provide security for a data means unauthorized person cannot access the data. Unauthorized person cannot destroy the data. Data in the system cannot be lost automatically. That means that whenever if you prevent these three factors, first one is lost, destroy, or unauthorized manner, we can say your data is in full security mode. That can be happen by providing the firewalls. And data integrity means accuracy. How much how much the data security is accurate. Consistency is our data is secure, and completeness of the data. All the data which we maintain will be available for long period of time. It means that the data should not be modified. The data should not be corrupted in any manner. Suppose whatever the data we are maintaining in our secured manner, that data cannot be modified, cannot be corrected automatically by any cost of point of view. That means that providing data integrity to the data security. Here, data security is played an important role for maintaining the data integrity. So both are interrelated together. So that means that if you provide a well-defined security for a particular database, that means that the data which is available in the database cannot be authorized, cannot be destroyed, cannot be lost, and it cannot be modified or corrupted at any point of view. So that means that our data is in very full secure mode. So that means that why I am talking, we will discuss about this. We are hosting lot of data in private or public or hybrid clouds. Whenever we are maintaining huge amount of data over public or private or hybrid cloud, we can have some assurance that the cloud providers are we are having assurance for that, because whatever the data we are posted about the cloud, that is well secure. That means our data cannot be modified, our data cannot be destroyed, or whatever the hosted data is cannot be authorized by the third party. So that means that our data is very secure. Take an example, Google Drive, Google App Engine, or Google is one of the cloud. The Google is providing one software as a service, that is called Google Drive. If you hosted or stored your personal data in our Google Drive, the data cannot be accessed by third party without your permission. Data cannot be modified. Data cannot be corrupted without your permission. That means that you can ensure that, or you can say that your data will be running in a secure mode. Your data will be hosted in a secure cloud. So that's why we can consider, or we can trust that cloud is always running with a secure manner. Otherwise, there is no demand for cloud. None of them will approach for cloud for hosting their sensitive data over a period of time or long time in the cloud. Here, we will talk about network threats and consider the diagram here. So here, key security requirements which are considered for most internet service providers. The first one is confidentiality, integrity, and availability. Suppose, for example, loss of confidentiality is one of the factor. If the network lost the confidentiality, whatever the information posted, there is a possibility of leaking the information. If the data is not tightly integrated with the network, so the integrity violations will occur. That means data leakages will occur. Once the data will leakage and our accounts will be seized and the data will be theft by third party. Loss of availability, which means that denial of services. There is no interrupt of the services. Whenever you want to post the data, you want to retrieve the data, automatically the data can be performed, the post or the access, both. Otherwise, if there is no security, you may face difficulty for losing or you may face difficulty for posting the data. Improper authentication. That means that the data can be used or utilized by an authorized person only. Otherwise, improper authentication means third party members will access the data, they may store in the data, and your data will not be in the secured mode, we can say. So, these are various network threats we are facing in our daily life. To overcome these network threats, our data integrity, our data availability will be protected over a period of time with a huge security manner. Friends, we discussed the security also. Next, we move to the last factor, energy efficiency in distributed computing. Energy. Energy is one of the important factor. Energy means if you want to run a computer, some energies are required. The first one is power. Power consumption, power efficiency. Power is also one of the efficiency. How to control the power? Or if you want to host your application into the cloud, internet bandwidth, that is also energy. Huge amount of data. If you want to access, if you want to host over the internet, over the cloud through internet, you need very high throughput bandwidth. So that is also one of the energy. And data centers. For maintaining the data centers, you need lot of storage devices. For that also energy is required. For maintaining the data centers, energy is required. Or suppose networking concepts in LAN, WAN, local area network, wide area network. If you are working on that, in that network, some routers or some other configuration paths are running. So for that, some energy is required. So in various level, middleware level, so there are different layers. In each and every layer, the energy efficiency is one of the factor. Let us discuss those in next slide. There are many techniques and algorithms used to minimize the energy consumption. Some of the well familiar techniques here we listed. The first one is virtual machine. Virtual machine is nothing but it seems to be a single machine. A machine seems to be a single machine, but within the machine, another machine is embedded and that is functioning. That is called virtual machine. That means that two or more machines which are embedded into a single machine, but finally it seems to be a single machine for the external point of view. That is called as a virtual machine. A machine within another machine with the same configuration, with the same operating system, or with the same hardware is considered as a virtual machine. So this is one of the energy efficiency. Another one is dynamic voltage and frequency scaling. So the voltage is dynamic. It is not static. It is dynamic. It may vary. The voltage is vary, power up and power down, and frequency scaling. Frequency is nothing but the number of inputs and the number of outputs which are traveled over a period of time. That is called the signal strength. The signal strength is scaling down sometimes. The signal strength is scaling up sometimes. That is also depends on the energy efficiency. And last one is virtual machine consolidation or virtual machine. migration. Sometimes we need to migrate the virtual machines. Sometimes we need to consolidate the virtual machines. That is also depends on the efficiency, energy efficiency. Let us consider the energy efficiency with a simple architecture over here. Here the architecture is split into four different layers. The topmost layer is application layer and the down layer is network layer. Meanwhile, we have used two different layers. One is middleware layer and another one is resource layer. Down layer is network layer. Network layer, if we are working on a network, what we have seen is some of the network related applications, network related devices are routers. What router will do, what switches will do, and what fiber optics will do. These are used in bandwidth. These are used in fiber networks. These are used for internet services. Networking layer, these three are used. They may convert the analog signals into digital signals. They may convert the digital signals into the fiber. Digital signals will be transferring over the fiber cable. So these four are energy efficiency devices. That means that if you are working on a internet at home through LAN, so with two or more different computers, all the computers are which are interconnected together, and those computers will be connected to each other. All the client systems will be connected over the LAN each other with the help of the switch, with the help of the router. So meanwhile, how much energy a switch will take and how much energy a router will take in terms of speed, in terms of throughput, or in terms of some other factors that can be measured as a energy efficiency. That means that how we can improve the router efficiency, how we improve the switching efficiency. So in a network layer, uh, next we move to another layer, that is a resource layer. Resource layer is nothing but we client missions here. The client missions is a telephone or a desktop system or a supercomputer or a huge server or a laptop. These five are considered as a resources which can perform sending the request to the server and the server will respond for automatically. For that, how much energy is required? Laptop. If you working with laptop, how much energy is required? How much power is required? Or how much bandwidth is required? So, how much if you are working with a desktop system, how much the energy efficiency? Which one is very efficiency? So we can select that one and we can operate that one. And next move to middleware. Middleware layer acts as a bridge among application layer and resource layer. It is acts as a bridge between application layer and resource layer. Here, the layer provides resource broker, community servers, task analyzers, task schedulers, security access, reliability control, and information services. All these are considered as a middleware layers. So these can be performed their own tasks whenever they can transfer the data over a period of time from resource layer to the application layer. The resource layer consists of a wide range of resources including computing nodes and a storage. And whereas the application layer here, the application layer is running with high energy physics, whereas in weather forecast also one of the application. That means that let us consider a simple example. If we are working with a distributed operating system, if we are able to perform the able to perform the efficiency of weather forecasting application, the what are the network layers, which one is required, whether we go for fiber, we go for switch, we go for router, or which computer we can use for sending the request, we go for using the desktop, we go for using the laptop, go for using a telescope. For always we can consider minimizing the energy, efficiency will be improved automatically, or which is the suitable middleware for that one. So all these will be considered a factor for performing a particular task over here. Next, move to another one is energy models. There are various energy models which are listed over here in a circular mode. The first one is data center energy use. Data center energy use means what is data center? Let us discuss. Data center is considered as a collection of servers which are interconnected together to form a data center. So for that, we need to spend huge amount of data for maintaining the data centers in a hosted environment. When companies use their dedicated data centers, they need to have a lot of resources which primarily involves. That means that for maintaining the data centers in a cloud or maintaining the data centers in a on-premises mode, we need high AC. Air conditioning is we need to provide air conditioning. Always the servers will be available, will be kept in a cool mode, and a particular dedicated hardware also available. For that hardware also we need to set up, and resource persons, a well defined or well trained people also deputed for measuring the performance of the data centers over the period of time, and power backup, maintaining the data for performing the task over a period of time without any failures. We need to maintain UPS backup also, and we need to provide the security for data centers. So if we provide all these concepts, we can say the data center is running with a very efficient model. Next, we move to another one is networking equipment energy use. Network equipment energy use, we will consider a diagram here. Energy, lot of energy wastage in inefficient handling. If you consider here, if you consider the right side, all the switches, the wires or nodes are well connected in a proper manner for a switching mode. If you consider in the left side, is the wires or the nodes which are not well connected to the switches in a proper manner. That means that it may lead to inefficiency in handling the energy, due to which lot of energy will be wasted. If we structured, if we plugged nodes well for a circuit node, the efficient handling by the cloud service providers, this can be done by cloud service provider. If you approach the local, they are not well defined, they are not maintained well. That means that energy efficiency is very high by cloud service providers, energy efficiency is very low for a private network. So here power consumption is decreased in cloud computing. Private and public cloud storage services are more energy efficient than storage on local hard disk drive when files are only occasionally accessed. That means that if we hosted our services over a private and public cloud, thus that is having better storage capacity rather than maintaining in a local disk. Thank you, students. So we came to the end of the session. In this session, once again, we will summarize the topics which we discussed over past 50 minutes. The first one is how to provide security for the cloud, how to provide energy efficiency for the grid or cloud computing technique, how to provide performance for a cloud with the help of the fault tolerance. We discussed this. So students, we came to the end of the unit 1. So almost as per JNQ Kakinada syllabus, all the topics I have been covered in 7 video lectures. So all my video lectures are available in Google Classroom. You may download or you may watch the videos anytime, anywhere, based on your demands. So next class, I will conduct one exam. The exam is about to 25 to 50 questions. Only I will conduct exam. So in that exam, I will see your performance in Unit 1. You be ready for facing or submitting the MCQs which are covered in my PPT or in my slides or in my videos. If you watched all my videos, you are able to answer the questions. Hope everybody will score good. So we will get back to you in next class. Thank you. Thank you so much.